I would like to take this opportunity to share a project that we've undertaken for a global power systems manufacturer. It was a project that took part as their innovation initiative. It was an innovation initiative to understand the potential value and impact of digitization and digital technology on their manufacturing and services operations. Our aim was very much about being able to challenge current operating philosophy, to challenge current ways of working, and to really help demonstrate the art of the possible. Our starting point, unsurprisingly, was actually what are the problems we're really trying to fix here. And summary in this case was one, it was around reducing engine build time, and this was further driven by an extremely strong order book and competitive cost pressures. The second challenge was really around reducing engine time out of service, and particularly unscheduled, unplanned downtime for the customers using their power systems. The third one was this organization has a huge organization of skilled service field engineers, both during the build process, test process, overhaul, and in services. But it was seen that they weren't necessarily able to get the most out of them when it came to scaling, so capturing the knowledge and scaling that out globally. So this was seen as a challenge set to us. And finally, making sure that availability and continuity of service, safety of service continued at all times. Now these are clearly quite significant challenges that any organization would be familiar with in this sector, and some clearly significant opportunity attached to it. Also able to attack this problem in a number of ways. The way that we chose was through the lens of digital. So how could digitization and digital tools be able to address some of these challenges to create demonstrable value? We started by creating a very simple hypothesis, looking at the concept of being able to combine IoT, networking, and collaboration technology in order to create much greater insight into manufacturing and services operations. To help prove this hypothesis, we created a set of questions for us to answer during this project. The first one was around how could closer human-machine collaboration help to improve decision support processes and tools in place today? The second one was how could we take advantage of closer integration of machine data and contextual information in order to create new insights into those processes? The third one challenged us to see how we could reduce the time taken to identify anomalies and deviations in manufacturing, so in assembly, in test, through overhaul, and through services, in order to reduce time to fix and time to respond to problems. And finally, we were challenged to say, well, throughout all of these processes, when we typically respond to challenges like this, there are real nuggets of experience and knowledge created that we fail to capture. So within this world, how can we make sure we develop that space around developing knowledge management? We took a pragmatic approach following agile development techniques and chose a use case which was around specifically how do we respond to problems either in manufacturing test or out in service. And these are typically problems that required expertise, specialist experienced engineers at site to look at these in order to identify, diagnose, and to respond to the challenges. But typically these were also situations where it wasn't actually so easy to ensure the right expert was in that right place in an acceptable amount of time. So a significant challenge there for us to deal with. So our objective really that was set to us was, well, how can we ensure that we can get those people together, all the right information together, much faster than happens today, to the specific nature of the problem. And our solution, we worked on three main capabilities. The first one was around edge analytics. So being able to, in real time, continuously monitor the state of engines, materials, components on those engines. So being able to take sensor data feeds at the point of activity So that means on the engine, on the components, on the subsystems, rather than being able to use the old traditional method of backhauling all the data into some data center and then applying algorithms onto that, onto something that has happened already in the past. Okay? The second area was this concept of dynamic virtual collaboration spaces. So based on the specific nature of the problem that was being tackled, can we look at that and make sure we then bring the right people that have experience in dealing with that problem, and then before they even arrive into this space, making sure that all the relevant information is there. And when we did the previous process analysis, there were huge amounts of manual time wasted there that we can effectively automate. And then the third capability around this was we needed to make sure this was as simple to access as possible. We wanted a seamless, easy user experience. And so one of the areas we were experimenting with was around natural language. Natural language interfaces to machines, to processes, to applications. I'll talk through a simple scenario just to illustrate the solution that went in. The story starts with a dashboard where we were monitoring various sensor data inputs from the engines. So it's using the edge analytics, and then sort of just again for illustrative purposes, we can assume that analysis based on correlated data may in this case suggest there was potentially an overheat condition with one of the components. What then happens, so we're using our Cisco Spark platform to generate those alerts, so working directly integrated with the edge analytics capability to not only determine what the likely cause was, to alert the right people of those cause, but it was actually about bringing those right people into this collaborative space that was created dynamically just for that specific problem. So the right people, didn't matter where they were, didn't matter where the information was, it would be brought into one space, regardless of the type of mobile device that was being used. In this example, we can see one of the first use cases we delivered was with augmented reality headsets. And if we can play the video, we can start to see that there was real live data that that person can see, the alert. They can also then interact with the other people that they think are most qualified. So that person can literally step into the problem, looking at all the right data, maybe sharing contextual information that the system has brought in. Being able to then, again, interact with other applications. In this case, the local engineer, through just normal voice, through the AR headset, is able to interact with a SAP database doing a part stock lookup for the repair. And then after the operation is completed, we saw an interest in being able to bring the teams together that were involved in this process to actually go back through what happens. Now, in this illustrative example, it was just 2 people in there. But what we've seen in reality is there are often teams of sort of up to 10 to 15 people that we can bring back in, and we step through the process and look at, is there a better way of doing it? Why did we do it this way? Could we have made a different decision at this point? And the interesting thing is all of these interactions through the process, so the video, the voice, the analytics, the real-time data, the documentation used, all of those steps are captured so that we can use that for future education, for learning, and actually integration into future knowledge management processes. Also, obviously, one advantage of that is this is audited. So we know exactly what happened and when. And that can be referred back to, obviously, in many years' time if necessary. One of the learnings from this was that as more and more physical objects, assets, get connected, get network connected in through supply chain, manufacturing, and services, a number of quite big questions get asked. And one is, actually, how do you manage that? How do you manage all those new objects coming in? You know, you see all the huge projected growth rates, and this is specifically around, how do you provision those? How do you move things around between locations? How do you decommission them? And then the big topic around that was, oh, and by the way, how do we make sure that we not only do that without disrupting operations, but it's done securely? And we realized very early on that none of this use case would be deployed without the appropriate security. So here we were using our software-defined access capability to put together profile, relationship, policy-based rules to ensure that all of those devices coming in within this environment could be appropriately managed, whether that was internal employees or in fact out to OEMs and to third-party service organizations, which was the next step that we were asked to do, to extend that model out to ensure those third parties could be accessed. And then also now a more emerging requirement is for us to extend that security architecture model so that we're also taking more sensor data and being able to actually securely pass straight into some cloud-based applications. If we look at the results of the project, what we're seeing is by bringing together this IoT, the networking and the collaboration into one platform, we're seeing benefits, as expected early on with the initial challenge, around bringing people together much faster, having the right information to hand much faster, and that is definitely, we're seeing a direct correlation to the KPIs that currently manage time to respond, time to fix the problems. So that's great. But actually we realized there's a whole lot more than that on top of this through running this project. If we look at the closer integration of the machine data, of the analytics, of the engineering know-how and knowledge out there, and combine that with the closer human-machine collaboration, we're starting to really see how we can finally challenge current operating philosophy. And in many cases, we're seeing philosophies that have remained unchallenged for many, many years. They've just been done that way always because they've always been done that way. So we're starting to see this really as an interesting example of how we've moved not just from a project that helps improve informed decision making and time to fix, but actually one that we're really starting to seriously challenge actually the face of work as we see it today. One last thing I really wanted to cover was that I talked about the underlying platform, which was this about bringing together IoT, it was about bringing together networking and collaboration. But this was really just for this one use case of being able to bring together remote engineering expertise to fix a problem as fast as possible. But what we're seeing is actually this same platform, as we start to share the project that we deployed to other areas, other stakeholders in this organization, a number of other applications were being asked of us. Could we deploy something on top of this? So for example, one application that we're now looking at is using this platform to gain greater visibility and insight into how energy is consumed within some of their key manufacturing processes, with a view to reducing consumption, associated cost, and GHG footprint. Another one we're looking at is using this as to be able to deliver the concept of digital threads and a record of life for materials, components, and whole systems, and the relationships between all of those for full life, and using that almost as an information platform on its own to be able to create new application services on top of it, to tap into that through life data. So we see that as a really interesting opportunity, because every time you layer one of those extra applications on, it just further strengthens the business case for investment in this solution. So it really works for all of us, and that's why we see this as a really compelling solution and a compelling argument that really is seriously impacting the face of manufacturing and service operations in this organization, and we expect it to go to beyond that. So I'm going to close there. I'm conscious this is a Friday afternoon, and we're trying to reduce the time for some of these presentations. Everything we have here, if anybody wants to discuss further the use cases, the technology, the good news is a very short journey, literally just 2 meters across there to our Cisco booth. So thank you for listening, and I wish you a successful rest of the show. Thank you.